For example, helium plus, then you have lithium double plus, etc. And we have seen the expression for radius, that was Rn. It means the radius of orbit depends on principal quantum number small n, and that was 4 pi epsilon naught n square h cat square divided by mass of electron into atomic number into E square, where small e is the electronic charge. So you see the radius is depends on principal quantum number. In short, you can write it like n square a naught divided by z. Okay, where a naught is the Bohr radius. Okay, so for helium ion, the first Bohr orbit will be smaller as compared to hydrogen. Then we have also seen that speeds is basically E square by E square z divided by 4 pi epsilon naught nh cut. Okay, and in fine structure form, we can write it like alpha c z by n, where n again can be on, 2, 3, and so on. Okay, it means for electron in helium ion will have large speed for particular state or particular orbit, okay, as compared to hydrogen. Then we have also seen that expression for energy, total energy of that electron, is a function of principal quantum number, and that value was minus me e to the power 4 z squared divided by 32 pi square epsilon naught square n square h cat square. In short form, if you substitute this value, mass of electron, charge of electron, epsilon naught, h cut, you will get basically minus 13.6 z square divided by n square, where n again on, 2, 3, so on. Okay, it means that energy level is discrete in nature. Okay, so today we'll solve one problem, then we'll proceed for correction of energies, radius, and speed for finite mass of nucleus. So let us solve one problem, one beautiful problem. So in that problem, it is given that, let us assume Tg represents the kinetic energy of electron in the ground state, GS means ground state of hydrogen, in short form capital H, atom. Okay, and Te subscript E is the kinetic energy of electron in third excited state of a hydrogen atom. Hydrogen means capital H. Then you have to calculate the ratio of kinetic energy of ground state to that of third excited state. That you have to calculate how much it will be. So how will do this? Anyone in the class? How will do this? Anyone in the class? Please respond me so that I can understand. So it is very simple and very interesting. If you remember, we have derived that relation between kinetic energy and total energy. Is not it? So basically the kinetic energy of hydrogen atom in ground state or any state, if you see, T is nothing but minus of total energy, but T is the kinetic energy of particular state and E is the total energy of that state. Okay, so for ground state, if you write for ground state, G dot S dot mean ground state of hydrogen atom, so you know that kinetic energy will be how much? Simply the ground state energy of hydrogen atom minus the ground state of energy of hydrogen atom. And you know this value, right? The ground state energy is how much? Anyone in the class? For a hydrogen atom, that ground state energy will be how much?
Minus 13.6.
Minus 13.6. Very good. So it will be minus 13.6 in electron volt. Now if you substitute it here, you will get how much? You will basically get that Tg is 13.6 electron volt. So it will be minus into minus, it will be plus. So Tg is basically how much? Plus 13.6 electron volt. Now similarly, you can calculate that third excited state kinetic energy. So if you write it in short form, so T, that E means third excited state, that is given. It should be equals to minus E of E. Okay, and this E of E will be how much? Anyone? So E of E will be how much? So this will be basically minus 13.6 divided by n square. So for third excited state, n is how much? 4, right? I told you for third excited state, n will be 4. For first excited state, n is 2. For second, n is 3. For third, n is 4. So 4 square means, so it should be 4 square. Now if you insert this value here, you will basically get 13.6 divided by 4 square means 16. So the unit will be electron volt. Now you can calculate Tg by Te. It will be how much? Anyone? So Tg by T will be, Te will be how much? Every people understood in the class? Any problem?
No, sir.
Okay. So now you got this value that Tg will be, Tg is basically plus 13.6 electron volt and that T is basically 13.6 divided by 16 electron volt. Is not it? It is correct, right? Now let us assume this is your equation number 1 and this is your equation number 2. Okay. Now if you divide equation 1, divide equation 1 by 2, how much you will get? On the left hand side you will get Tg divided by T of E, that should be equals to how much? 13.6 divided by 13.6 by 16. So 13.6 will be gone and this 16 will basically come to numerator. So it will provide you 16. Okay. So it means the ratio of kinetic energy of electron in the ground state of hydrogen atom to that of the kinetic energy of electron in the third excited state of hydrogen atom will gives this value. This value is nothing but 16. Every people understood in the class?
Yes, sir.
Is it clear?
Yes, sir.
Okay, very good. Now one important thing in atomic physics that was basically ignored by Bohr or Bohr model. So what he has done, he has assumed that nucleus mass is infinity. In hydrogen atom, he has assumed that the mass of the nucleus is infinity. But this is not true. In hydrogen atom, you have proton, right? So proton has some mass. How much mass it has? So basically the mass of proton in energy unit, if you see, it is basically 938 MeV per c square in energy unit. So it means it has some finite energy or finite mass it has. So now the problem is basically two-body problem. You have on fellow is sitting at the nucleus, and on fellow is orbiting that nucleus, right? That is nothing but electron. So this is the basically two-body problem. So two-body problem, any two-body problem can be solved by introducing that concept of reduced mass. I'm sure you people have heard about that reduced mass in planetary motion, right? So you have to introduce when you are considering that mass. So let us assume for hydrogen case, you have proton inside nucleus and electron is orbiting this nucleus. So let us assume that mass of the electron is me. So the reduced mass of this system will be how much? Anyone? So reduced mass basically denoted by mu, and that is nothing but MEMP divided by ME plus MP. Now what Bohr has done, he has divided this equation on numerator by MP and denominator by MP. That you can do. If you do this division, what you will get? So ME by MP divided by MP, then again divide ME by plus MP divided by MP. So this MP will be gone. So what you will basically get, mu is nothing but mass of electron divided by this. If you divide it, you will get basically 1 plus Me by MP. So what he has done, Bohr has done, he has considered this mass is infinity. So if this is infinity, so something by infinity will be 0. So this term he has considered 0. He has considered this mass, this ratio is 0. So basically reduced mass comes out to the mass of electron, and he has considered this mass, and he has calculated all this radius, speed and energy. But this term actually is not 0, right? Because this is some finite value. So finite by finite will give some number. So you have to definitely do the correction in Bohr model. So what you have to do, you have to introduce that reduced mass concept in radius expression, speed expression and energy expression. So now what you have to write in terms of that, in place of mass of electron, you have to insert the reduced mass of the system. So if you remember, just now I just 5 minutes or 10 minutes back I wrote that that expression. You have to introduce that reduced mass there. So I'll do that, and you see that beauty. Is that clear to everybody? What I have said, is it clear? Is it clear to everybody? Is it clear? So, sir, if you remember that expression for Rn for hydrogen atom, what I have wrote, that was 4 pi epsilon naught n square h cat square by me square, right? But correction, you have to do that correction. Now what you have to do, you have to replace that me by the reduced mass, that is nothing but you have to replace by mu. So that express a correction, the heading will be correction due to correction due to finite nuclear mass. And this is very important actually. You cannot ignore the mass of the nucleus, or you cannot say that the mass of the nucleus is infinity. Okay, so you have to make that correction in the radius and speed and energy. So what you have to do, just you have to replace that me by the reduced mass, that is nothing but mu. Okay, did you get every people? Shekhar, did you get what I'm saying? Shekhar, did you get what I'm saying?
Sir, get.
Okay. Karthik?
Yes, sir, got it.
Okay. So are you enjoying that class? Any problem in the class? Everybody?
No,
Are you enjoying that class?
yes, sir.
It's really interesting, and in future it will help you. Okay, so very important. Okay, so please make sure that you are getting all that information what I am saying. So if you see that expression, Rn will be how much now? It will be simply 4 pi epsilon naught n square h cat square divided by, now I will not write that mass of electron, I will write the reduced mass of that system. So I will write mu into E square. So this will be the radius, and let us assume this is Rn bar, because you have already defined Rn. That Rn was how much? It was 4 pi epsilon naught n square h cat square divided by me into E square. Now you have replaced that me by mu, so you have to change that notation also. Now let us assume that radius is nothing but Rn dash. Now one beautiful thing we can do, we can multiply and divide this expression by me. We can do it, right? No problem. If we multiply this expression by me by and divide by me, we can do it, no problem, right? Now what I'll do, I'll take this me here and I'll keep this mu here. So at the end, if you do it, how much you will get? You will definitely get 4 pi epsilon naught n square h cat square divided by me into E square, and also you will get me by mu. Is not it? Just I replace that position of me and mu. Okay, I keep this mu here and I take this, bring this me here. So if you bring this me, now remember this is the actual radius of that what Bohr has derived. Is not it? If you remember this, this is nothing but Rn. This is nothing but Rn. That was the radius of nth orbit of hydrogen atom. So what you are basically getting after this correction, you will definitely get mass of electron divided by reduced mass of the system into Rn. So that Rn dash is nothing but me divided by mu into Rn. So Rn dash due to the finite mass of the nucleus, and that will be nothing but mass of electron divided by reduced mass of the system into the nth radius of nth orbit of hydrogen atom, what Bohr has derived. Okay, did you get what I'm saying? Did you get what I'm saying? Any doubt in the class? Now we'll similarly we'll check the speed expression. We'll insert this mu in speed expression also. Now we'll see the effect of mu in speed. Let us check. So if you remember the expression for speed of nth orbit of electron in hydrogen atom, so it was basically, it was nothing but E square, where E is the electronic charge, divided by 4 pi epsilon naught nh cut, where n is the principal quantum number, h cut is the reduced Planck constant. Now you see, if you insert that mu here, you can clearly see on the right hand side there is no mass. Speed is independent on the mass. So whatever correction you are doing due to the finite mass of the nucleus, there will be no effect on the speed because it is independent on mass. So what you can basically write, Vn dash is nothing but Vn. So after that correction, there will be no change in speed. Did you people get what I am saying? Everybody,
Yes,
did you get what I am saying? Students, are you getting?
Yes, sir.
Okay. Are you enjoying class?
Yes, sir, very much.
Okay, okay, very good. Okay. Now look at energy expression. What will happen? look at energy expression. If you remember that energy expression, energy
Sir,
of, yes,
sir, if there is change in mass, then there is change in, then there will be change in velocity, right?
yeah, that was the beauty thing. But what that expression is telling. This expression was independent on, if you remember, not only that mass is playing that role. What is happening, you see, when you are changing that reduced mass, then radius is changing, right? When that question was really depth, I appreciate it. What she is saying, if that mass is changing, basically this is reduced mass. So if mass is changing, she is saying that definitely there will be change in speed. And that question is valid. It's a really good question. But you see, what is happening when you are introducing that mass, there is a change in speed, right? Sorry, there is a change in radius. When you are introducing that reduced mass here, so there is change in radius. If there is a change in radius, there will be change in speed, but that speed is basically balanced by that mass of that reduced mass. Actually, what is happening, when you are changing that mass, radius is changing, and due to this change of radius, there will be change in speed also. But that change is basically balanced by that change of mass there. That's why there will be no change in speed. Please keep in mind, because you can see that what derive that expression for speed, you can check here. That question, if you see in reality, if you can think, if the mass is changing, definitely there will be change in speed. But if you see Bohr model, when that radius is changing, there will be change due to that radius, that speed will be changing. But another effect is due to the mass, and that actually balancing. So due to this, there will be no change in speed, and you can clearly check from here also. If you check that expression of speed, that was nothing but E square by 4 pi epsilon naught and h cut. And that question, what you are asking, that's why once TIFR asked this question, that if you are changing that mass of that nucleus, then what will happen to that speed? And every people made that mistake. What they have done is valid. You are changing mass, then there will be change in speed. But that is not true. From this expression, you can clearly check. So whatever mass you are changing, there will be no effect on speed. And this expression basically telling you that story, because it is independent on mass. It is depend on charge. It depends on quantum number, principal quantum number, but it is independent on the mass of the electron or mass of the system. Did you got that answer, or any doubt now? You got the answer?
Yes, sir.
Okay, thank you. Any more question? Any more question?
No, sir.
Okay, very good. Now, can you please write that expression for energy? So UN will be the total energy of the system. That will be nothing but, if you remember, I have derived, that is me e to the power 4 divided by 32 pi square epsilon naught square n square h cut square, right? Now, due to that finite mass of the nucleus, what I have told, just you have to replace this by reduced mass. Again, I'll multiply this expression by me and divide by me. Okay. Now I'll bring this me from here to here, and I'll bring this mu from here to here. So ultimately, let us assume this is En dash. So En dash will be nothing but minus me e to the power 4 divided by 32 pi square n square epsilon naught square h cut square, and you will have mu by me, right? You will have mu by me, is not it? Did you get what I'm saying? So this thing you can write, if you remember, this is nothing but n. The energy of nth orbit of hydrogen atom what Bohr has derived. So you can write basically En dash is nothing but En into mu by me, where mu is the reduced mass of the system. So En dash, this is energy due to finite mass of the nucleus, that will be nothing but En what Bohr has derived. Please keep in mind what Bohr has derived, that is basically En, and that is multiplied by mu divided by me, where mu is the reduced mass. Now it is clear everybody that the mass can affect the radius, finite mass of nucleus can affect the radius, it can affect the energy, but it cannot affect the speed. Okay, is it clear to all? Is it clear to all?
Yes, sir.
Okay, very good. Now we'll do one beautiful problem. So please write that problem. So if write that problem, huh? If positronium is a short bound state, if positronium is a short bound state of electron and positron, then calculate, if positronium is a short bound state of electron and positron, then calculate the energy, frequency, wavelength of L alpha line. L alpha means Lyman alpha line. Okay, Lyman alpha line. For that you have to calculate energy, then frequency, wavelength. Also calculate the radius of first Bohr orbit of this positronium system. So what you have to calculate? First you have to calculate the energy, frequency and wavelength of Lyman series or L alpha line. Then you have to calculate the radius and speed of positronium in first Bohr orbit. Every people wrote that question what I said. So you have positronium. Basically what is happening? Positronium means in nucleus now you will have one positron. Positron basically positively charged. Now in positronium, the at nucleus there will be no proton, only positron is there, and electron is orbiting around it. So first, before doing any calculation, you see the mass of the nucleus is finite and it is same as the electron. So you have to calculate first reduce mass, then you have to go for energy. So shall I proceed to solve this question? Please respond me so that I can proceed. Shall I proceed for solution?
Yes, sir.
Okay. If you wrote that question or any doubt? You have completely written that question or or shall I repeat that question?
Written, sir.
Okay. So let us go for solution. So let us calculate the reduced mass of that system first. So if you calculate that reduced mass of the system, so reduced mass will be mass of this fellow positron has same mass as electron. So basically it is me and mass of electron is me divided by me plus me, and it will provide you me square by me square divided by 2 me, twice of me. So on me will be cancelled. So reduced mass of the system you will get basically mass of electron divided by 2. So this is the reduced mass of the system. Now I'll write that energy expression for this system. If you remember, due to finite mass, I have written that energy expression. So you wrote, have you written this expression? Shall I erase?
Sir.
Okay. So this much reduced mass you have. Now if you see, now if you see the energy expression due to finite mass or nuclear mass, what I have written, that was nothing but mu y me into En, right? Where En was how much? According to Bohr, you know that En value, right? En was nothing but minus 13.6 by n square. This was your En, energy of nth level. And for this positronium system, you know this value, right? This value just I have written that or derived, that value was me by 2. So nth level energy for this system will be En dash, and that is nothing but mu was me by 2 divided by me, and you have En. Okay, so this me will be cancelled. So how much you will get? En by 2. And just now I wrote that expression for En, that was how much? Minus 13.6 divided by n square, and you have 2. So basically you will get 2 times n square. Any doubt? So for positronium system, the energy expression now, it is no longer minus 13.6 by n square, but it is minus 13.6 divided by twice n square. So for this expression, that expression that Bohr has derived, that is not valid. So it is basically divided by 2. Okay, everybody cleared? Did you get what I'm saying? Any doubt in the class? Are you enjoying that class? So now I asked to calculate the energy for Lyman alpha line. So for Lyman alpha line, so just please write this first. Minus 13.6 by 2n square, where n can vary from 1, 2, 3 and so on. Okay. Now if you remember, for Lyman series or Lyman alpha line, what I said, the transition is happening from where to where for Lyman alpha line? Anyone? For Lyman alpha line, the transition is basically happening from n equals to 2 to n equals to 1, right? This is known as Lyman alpha line, or basically L alpha. Okay, is not it? For Lyman alpha line, the transition is happening from n equals to 2 to n equals to 1. So energy of this line will be how much? Energy of this line will be delta E is nothing but E2 minus E1. Okay, so from this expression we will calculate E2 and we will calculate E1. So if you calculate E2, E2 will be how much? Anyone? So if you calculate from this expression, so E2 will be basically minus 13.6 divided by 2 times 2 square means 4. And you have minus E1. E1 will be how much? So E1 will be basically minus of 13.6 divided by 2. Clear? Is it clear, everybody? Is it clear?
Yes, sir.
Okay. Can you calculate now this value? How much you are getting? Anyone? So if you calculate it, you will get basically 5.1 electron volt. So this is the energy of Lyman alpha line for positronium system. Okay. This is the energy of Lyman alpha line for positronium system. In positronium, you have one positron locating at nucleus and electron is rotating around it. So in positronium, there is no proton inside nucleus. Okay. So energy of Lyman alpha line will be E2 minus E1, and for E2 for positronium will be minus 13.6 divided by 2 into 2 square. So it will be basically 8 minus of minus into E1. E1 is how much? Minus 13.6 by 2. So if you solve this, definitely you will get this number. Now if you know that energy, you can calculate the frequency of this whatever photon is emitting due to this transition. So how much will be the frequency? Anyone? So you got this energy of this emitted photon in Lyman alpha line, that is nothing but 5.1, and for photon you know E is nothing but h into nu, where nu is the frequency, and that energy was basically how much? 5.1 in electron volt. Okay, so nu will be nothing but 5.1 into 5.1 EV by h. Now you see, you know h in SI unit, how much the value of h? Anyone? Planck constant? So
6.62 into 10 raised to minus 34.
very good. So 6.6 into 10 to the power minus 34. Okay, and you have EV, so you have to convert it into joule, right? So how will you convert? So you have to multiply 1.6 into 10 to the power minus 19, right? So now this frequency you are getting in hertz, right? Or second inverse. Okay. So how much you will get if you solve it? 5.1 into 1.6. So why you are multiplying? Because this unit is in EV, so you have to convert it into joule. So for this conversion, you have to multiply 1.6 into 10 to the power minus 19. And h is Planck constant, that is nothing but 6.6 into 10 to the power minus 34. So if you solve it, how much you will get? If you solve it, definitely you will get nu will be nothing but, I have solved it, you please check it, 1.23 into 10 to the power 15 hertz, or you can say second inverse also, no problem. Okay, every people got? It's a really nice question, and the many parts are there. Very interesting question. You will get this kind of question in a competitive exam. Okay, now you have calculated sorry, extremely sorry. So you have calculated frequency. Now you can calculate wavelength. How will you calculate? So you know, for photon, nu equals to how much? C by lambda, right? Where c is the speed of light, and lambda is the wavelength of this photon. So you know this value, photon frequency. You know the speed of light. So definitely you can calculate lambda, associated lambda with photon for this frequency. So lambda will be how much? Basically c by nu. Is not it? And c is nothing but 3 into 10 to the power 8. Okay, divide by nu is how much? You have calculated 1.23 into 10 to the power how much? 15. Okay, can you please calculate it now? Anyone?
2.3 into 10
2.4 into 10
raised.
to the power minus 7, right?
Yes.
Everybody agreed in the class? Very good, very good. I appreciate. So now you are enjoying. I hope you are enjoying that class, right? 2.4 into 10 to the power minus 7 meter. So you have calculated energy of Lyman alpha line, frequency, wavelength. Okay. Now can you calculate the radius of first Bohr orbit? Can you calculate it? So how will calculate? So you know that expression, right? Rn dash is nothing but me by mu, right? Me by mu into Rn, right? So for fast Bohr orbit, n is how much? N is basically 1. Okay, so R on dash is nothing but me by mu into R on, right? Just now we have calculated that reduced mass of this system, so I'll insert it. So me mu is how much? Me by 2, and R1 is how much? R1 is the radius calculated by Bohr, and that was nothing but A naught, right? That was nothing but A naught. A naught is how much? 0.53 angstrom. So in place of R1, what I'll write? I'll write A naught. The value of A naught is how much? 0.53 angstrom. Okay. So the radius of first Bohr orbit of positronium will be twice of A naught. So it is, you see, the radius is now getting increased. So radius of first Bohr orbit of positronium is twice the radius of hydrogen atom in the first orbit. Okay, did you get? So you can think of, now the radius is getting increased. So although you are thinking that mass is getting reduced, but due to that increase of radius, speed will be decreased, and due to reduction of the mass, the speed will be increased. Both will be balanced, so that there will be no change in speed, although radius is getting increased. Just now you please remember, for the time being, the radius of that system is twice the radius of the Bohr orbit in the hydrogen atom. Okay, every people understood what I am saying, or any doubt in the class? Are you enjoying, every people?
Yes, sir.
Are you enjoying class?
Yes, sir.
Okay, now can you calculate that speed in the first Bohr orbit of positronium? So speed will be how much? So if you write this expression V and dash, sorry, that was alpha c by n, right? If you remember, the first orbit, and that is nothing but Vn. Okay, so due to the mass effect, there will be no change in speed. Please keep in mind. So for n equals to 1, this is known as first Bohr orbit. Bohr's orbit. Okay, so V on dash will be nothing but alpha c divided by 1, and that is alpha c. And I told you that value of alpha how much it is? Anyone? Alpha is how much? Alpha is how much?
1 by 137.
Very good. So 1 by 137 into c is 3 into 10 to the power 8 meter per second, right? So again you will get this number 2.19 into 10 to the power 6 meters per second. So it is exactly same speed as electron revolving in a hydrogen atom. You see, this speed is same. There is no change in speed. Okay. Now I hope you got that answer of your question. Is not it? Did you get?
Yes, sir.
Okay. Now one more problem I'll do. Okay. Please write that question. Okay. If V is the speed of electron in the second orbit of or second Bohr orbit of helium ion, He plus ion, helium ion. So V basically speed of electron at n equals to 2 in helium ion, helium plus ion. Okay. Now the speed, calculate the speed of electron in the first Bohr orbit of hydrogen atom. So what is given data? They have given the V is the speed of electron in the second Bohr orbit of helium ion. Now they have asked to calculate the speed of electron in the first Bohr orbit of hydrogen atom. Okay. Now if you remember, I am solving this. The expression for speed for nth orbit of hydrogen like atom was alpha Z alpha C by n, right? Z alpha C by n. So for helium plus Z is how much? Z is 2. Since they have asked second Bohr orbit, it means n is how much? 2. And they have given that speed is how much? V. So how much, what is basically you are getting for helium plus at n equals to 2, that speed is given as V, and that is nothing but Z is 2 alpha C by 2. So it is basically nothing but alpha C. So V is nothing but alpha C. Now is it clear to everybody? So V is nothing but alpha C. Now if you see that speed of electron in the first Bohr orbit of hydrogen. So for hydrogen, if you remember, the expression was Vn equals to, let us assume this is V dash because already V is given for helium. So let us assume this is V dash, and that is for hydrogen atom is nothing but alpha C by n. So for n equals to 1, how much you will get? Alpha C, right? So for n equals to 1, V dash will be how much? Alpha C, and that is exactly same as V. Okay, it means the speed of electron in the second orbit of helium ion is same as the speed of electron in the first Bohr orbit of hydrogen atom. Is it clear to all? Is it clear to all?
Yes, sir.
Okay. So now I should stop here. Okay. So tomorrow we will solve few more beautiful problem. Okay. That will really be helpful in your exam. Okay. Is there any question you can ask me? Otherwise, I will leave. Any question is there? Any question is there? Okay. Then I am leaving. Okay. Good night, all. Okay.
Okay, sir.
Okay. Bye. Huh? Bye, all.